Hello, everyone, and welcome to this session organized by Jnana Prabodhini Foundation's analytics team. We are a non-profit computational social science platform engaged in research, analysis, and policy making to build a better future. In today's uh, in today's session, we will be talking about analysis pipelines, going from raw data to refined insights. Let's begin with a very big question. What is data? We live in a data world, in a data age, and all of us have experience doing analysis, data analysis in some way, shape, or form. Whether we know it or not, all of our parts of our daily life are filled with data. And data in a professional context, in an academic context, in an industry context, can mean many different things. Simply put, data constitutes a large set of discrete quantities that have been measured. It can include numbers, information, graphs, facts, observations. And data can be from multiple domains. It spans from especially the kinds of data you would encounter in a computational social science context would span from natural data, transport, geographical data, cultural data, human behavioral and cognitive data, data from scientific domains. This data comes from lots of different domains. So different people, different organizations, different practitioners have different understandings of data. Even within computational social science, data is pretty widespread. It can come from many disciplines, such as anthropology, psychology, political science, and it can be generated and analyzed using lots of different computational tools, such as machine learning, geographical information systems, epidemiological modeling, and so on. Data can be quantitative or qualitative. And quantitative and qualitative data have both positive and negative aspects to both of them. So that none of them are inherently better or worse than the other, though, we seem to have a bias, which this XKCD comic hopefully addresses, of thinking that quantitative data is often inherently better than qualitative data. But survey data, interviews from people, these are examples of qualitative data which we can get. Finally, data can be big or small. And again, in this day and age, big data seems to be coveted and the thing to do. However, both big and small data have their benefits and disadvantages, depending on where they're stored, how much memory you need to store them, the way they're structured or organized, the formats in which they're stored, how reproducible they are, how shareable they are, and also the types of analyses that can be done with these types of data sets. Finally, data can be open or closed. And here is probably where one can pass more of a value judgment to say that open data is more desirable. We don't want data to be sitting behind closed proprietary doors as much as possible. As they say, data is the new oil, and ideally the oil should be in the hands of all people, not just certain vested interests. And it's really important when you are doing data analysis, especially computational social data analysis, to understand the data ecosystem that you're faced with. And I'm giving an example of the data ecosystem, where oftentimes the data sets that you are trying to get, trying to scrape may be closed data sets. You might have to jump through multiple hoops, go through multiple agencies, be it government or non-profit or some other, in order to get access to the data that you want. So yeah, just to summarize, this section, that data is diverse. It can have different definitions and sources. The nature of data is diverse. It can be quantitative or qualitative. It can be big or small. It can be open or closed. And when we talk about data, it is very important to be specific about what we are talking about. Otherwise, The same word can have many different meanings and connotations, and often we end up talking past each other. So it's also important to be aware of the fact that when someone else says that, oh, I have data or I'm doing data analysis, that they might be talking or referring to something very different. So being aware and cognizant of what different types of data analyses out there is important. Okay, moving on. Data alone is meaningless and useless. Data itself cannot really tell you anything, and data needs to be put into some kind of context. That is, the raw data points that you get, the raw data that you get needs to be refined and progressively transformed from data to information to knowledge and wisdom. And I'll give you a quick analogy about a very different field. So the food that you eat that comes from farm to table goes through multiple steps of processing, which involve value addition and transformation. A farmer might grow wheat, then that eventually gets to a factory, it gets converted into flour, then it turns into bread, then there's a whole management and supply chain, then it might enter the service industry, and finally you eat and consume these sandwiches. At each step in the process, your raw product, that is the wheat, is getting transformed, processed, and there is being some value added to it. Similarly, when we analyze data, when we go from raw data to refined insights, when we are going from data to information, to knowledge, to wisdom, we are adding something in the process. We are adding context, we are adding meaning, and we are adding new novel insights. And it's important to think about what stage the data that you're dealing with, the data that you're communicating, the data that you are processing as like a consumer of data, where it is falling in this pyramid. These steps in data processing, of course, require you to have some kind of question or start off with some kind of data which is out there in the real world. And that's before you even jump into this data pipeline. Once you have your question and you have your data, you go through multiple steps in this data pipeline, from data wrangling and cleaning, from exploring, from analysis, modeling, to validating the data and eventually telling the story. I should say this is just a data pipeline, and it is by no means linear. We'll come back to that point, that you iterate the step, you might go back in this process, depending on whether you're in an academic context or an industry context or a non-profit context. The kinds of data that you need to analyze are going to be very different. But overall, this general process is pretty similar. In today's session, we will be focusing on a simple data pipeline. This, of course, assumes that we have access to the data, though we'll come back to obtaining the data in the first place towards the end. We'll be focusing on 4 parts of the pipeline, from data cleaning to data transformation to data analysis and to data visualization. This is a very simple pipeline, but it presents a small distillable working model that you can refine and change according to your own purposes and requirements. First, we go into data cleaning. Data cleaning is honestly the most time-consuming aspect of the entire data process. It's probably the most frustrating aspect of the process as well. Data cleaning involves some things as simple as, fixing the spelling mistakes of the names or names of cities or names of geographical locations if you're dealing with geospatial data. It involves dealing with any missing values that you have or any NAs that you have in your data set. It involves handling missing data, managing unwanted outliers, fixing structural errors, and removing unwanted observations. And there's a lot that you have to do before you can even go ahead in the process. Many times we tend to be interested in the process and the products and the outcomes of data analysis and visualization. However, it is worth being cognizant about the fact that data cleaning itself is a very important part of the process. So what are some of the tools that you can use to clean and transform data to process it to into a usable format. We'll focus on two languages today, R and Python, but I can imagine all different languages have their own source toolkits. We focus on R and Python specifically because they are used in multiple industry, academic, research, and nonprofit contexts. Also, these are both open source languages, and the packages that we see are open source. They're free for you to use. So in R, the tidyverse is a very good package to begin with. It is pretty intuitive. It has a very clear language, and R is used more by statisticians, researchers, epidemiologists. And if you want to do more core rigorous statistical modeling, that's what you might want to look for. It's also commonly used in in computational social science. And tidyverse and the dplyr package are good like starting points for you to do data analysis if you're doing it within R. In Python, some of you may be aware that pandas and numpy are a good starting point to begin with. These allow you options to clean your data sets, to transform your data sets into the format that you need before you actually run your analysis on them. There's many different aspects to these, but it's useful to both of these have these readily available cheat sheets that allow you to transform data. And these cheat sheets not only give you an very easy access to what you can do with these data sets, but at the tip of your fingers, but it also gives you suggestions. Like if you have a raw data set and you don't know what to clean, or you don't know what transformations you might want to make, this is a good start point to do some exploratory work. And you might want to reshape your data from a long to a wide format. You might to filter out your data. That's very common, that you only need to be taking a subset of the observations, and you might be and you might be doing this subsetting based on rows, or based on columns, or based on the identity of some cells. So you might only want cells that have ones in them instead of zeros, or yes values in them instead of no values in them. So there's a lot of common initial types of data cleaning and data transformation steps that tend to be common irrespective of the kind of data set that you're dealing with. Moving on to data analysis. Data analysis is now when you have your data set, you've cleaned it, you've transformed it, and you are importantly trying to answer some kind of question or trying to solve some kind of problem. And what you do in the data analysis phase is really helping you answer that question or solving that problem. Data analysis is also arguably the most vast part of this pipeline. So we can obviously not go through all different aspects of data analysis in a 20-minute session. But it's really important to know what you're doing. So for example, if you have, say, the daily COVID-19 cases in a city, this is a city in Western India called Pune, over time, then you can maybe start asking questions such as, how were different areas of Pune impacted by the pandemic? So you might ask geographical questions such as, were different wards or regions of PMC equally affected across all three waves? And you might be interested in what kind of underlying demographic and socioeconomic factors may help explain the varied geographic impact. This is very important, not just to answer as a question, but also to help solve a problem, which is planning for infectious disease management and mitigation in urban settings. So you might start off with, say, with the data about case fatality rate in Pune across the three waves of the COVID-19 pandemic. And you might also have data about a socioeconomic indicator, such as the number of slums in Pune, which is you see on the right. And just by visually looking at it, by eyeballing it, you might have some intuition that, oh, maybe case fatality rate and the number of slums per ward in Pune may be correlated with each other. Data analysis allows you to take these intuitions and then do hypothesis testing, such as doing statistical tests where you're testing for correlations, maybe you're running some regressions, maybe you're computing significance values such as p-values to determine whether the intuitions that you have about data are borne out by the statistics. As we said, that this data analysis can be hypothesis driven, that you're coming out with a question. Maybe your question is, maybe your hypothesis is that the number of slums in a region is correlated with the case fatality rate of a region. And then you do the data analysis to test the hypothesis. Or you could start off by doing some more exploratory work where you have a data set, such as what John Kepler did with astronomical data. You have big data sets available, and then you start exploring them, trawling through them, and seeing if there are patterns. And both hypothesis and data-driven science are important aspects of both research, analysis, and policy making. Moving on to data visualization. Data visualization is also a really important part of the process, because now you're starting to move away from your own world of your own analyses and files, and you're starting to move towards the outer world, which you have to communicate your data to. It might be industry, it might be your clients, it might be academic journals or papers or policy documents. Data visualization is really important because you need to distill and communicate what the story you're presenting. It should be simple, it should be easy to understand, and you should not make your audience think more than they need to. Simplicity is a great virtue, and when in doubt, throw it out is a great axiom or maxim to keep in mind when you're designing data visualizations. Data visualizations can be static or dynamic. So here you see examples of geospatial visualizations like maps. So they can be static maps like those you see on the left, or they can be dynamic maps like those you see on the right. And this dynamic map shows is a temporal one where you see how COVID-19 spread, the third wave of COVID-19 spread geographically in Pune over a period of time. So it's important to think about what kind of data visualization you're coming up. If your audience, let's say you're working with a policy or a government audience, which consists of IAS officers and bureaucrats who have a lot of files, and they're just going to be printing out their files, you cannot probably do a dynamic visualization. But if your audience is the tech industry or scientific researchers, or maybe a conference talk or a webinar or a session like this one, you can integrate dynamic visualizations into what you're doing. Then it's useful to know what kind of standard visualizations that exist in the world and what kind of names that they are. So there are bar plots, there are pie charts, there are dot plots, there are line plots, there are forest plots. There's many different types of plots out there in the world, types of visualizations in the world. And knowing what these visualizations are, how you can use them to communicate what types of data is very important. You don't need to use it's often very embarrassing and very jarring when people use the wrong type of visualization for a type of data set, which could have been equally or much better communicated using a better type of visualization. Visualizations often can differ in how much or how little they communicate or show the data. So that's also something to keep in mind about what visualization you're particularly choosing. It's also important to remember that in, again, the age where we are all enthralled by data science, we should remember that data visualization is equally an art. So beyond these standard line charts and bar graphs and pie charts, you can get creative in the data that you're visualizing. I am a neuroscientist, so we work with visualizations of brain scans and brain regions. And very simple data, such as how many beekeepers are there in a per kilometer grid area, which could have been very boringly presented as a table or as a line plot, can be transformed and presented as a map, and not just any type of map, a very creative map that you see in front of you. So data and this creativity is where you can really bring in insights from design, UI, UX, and other fields to transform data and communicate it to the audience that you have in mind. Some common tools for data visualization are there's Plotly and ggplot2 are nice packages which are available both in R and Python. So you can use them in either of those languages. They have an array of different options that can allow you to create really sophisticated and beautiful visualizations, as well as simple ones. They have a lot of boilerplate template code that you can use to easily get started. If you are not really comfortable with coding, Data Wrapper is a great option for to allow you to get started using GUI, a graphical user interface. Figma is an interesting, is a very useful free option, open source option, which has many of the features, professional features available and that are commonly used by professional designers in proprietary softwares in a day-to-day context. And again, simplicity is key. I have personally found that if you know what you're doing, if you explore, you can create very nice visualizations, even in something as simple as Excel or Google Sheets. So start simple. You don't really need to use fancy packages, though they exist if you do want to. So just to summarize what you need to know for data visualizations, know what information and data you're presenting and be accurate about it. Be clear what the story is that you're trying to communicate. Be clear what your message is, and select what your goal is. So in terms of what problem is being solved or what question is being asked, know what your goal is when you're creating these visualizations, and present the information as a logical, coherent way. Make sure you have consistent colors, consistent palettes, a consistent visual language. Make sure that your color palettes are friendly for disabled communities, such as using colorblind friendly palettes. Red-green color blindness is one of the most commonly commonly occurring types of color blindness, and there is easily available tools out there which allow you to verify whether the palettes that you are using are color friendly or not. Finally, I'll end by saying that this simple data analysis pipeline that we went through, from data cleaning to data transformation to data analysis and data visualization, is incomplete. We have importantly left out two parts at the beginning and the end of the process. The first part is data scraping, data acquiring, data extraction. Getting your hands on the data is a difficult task in the first place, and that is probably worth a whole another conversation. Towards the end, after you visualize your data, you need to communicate it. You need to use that data to act upon it, to transform decision making. So communicating your data to stakeholders, acting upon that data, using that data to inform policy making in public health, in economics, in it could be to improve your company's profits. It might help you decide what kind of experiments should you be running. If it's a pilot experiment, it might help you what kind of grants you should be writing. Decision making with the data is the most important part of the process, which again we left out in today's simple conversation because of a lack of time. Another important thing to know is that this pipeline is actually not linear. You might be iterating through different parts of the process. For example, data cleaning and transformation often involves doing data visualizations to do have sanity checks of the data. You might come after doing a data visualization, you might notice a different pattern, and then you might go back and do some data analysis. So this is more of a recursive process, a cyclic process, rather than a straightforward linear progress where you can just say, okay, I'm doing step 1, it's finished, step 2 is finished. And therefore it's worthwhile thinking about the interoperability of these processes, thinking about when you're designing your data analysis pipeline, how can you potentially be equipped or competent to do all of the different parts of these processes simultaneously, and to make sure that if one part of the process is dependent on the other, knowing what the dependencies are and having a plan to make sure that you have what you need to do something. Like you can't make a graph if you don't have the data, for example. So that is all about today's session of analysis pipelines from raw data to refined insights. And we will come back with another session sometime in the next month. Thank you.